So I gave you a few questions last time on more complex trig equations. What I want to do in this video is I want to go through these questions with you, work out the solutions and show you how to approach them. So quick refresher for you, here's what the questions look like. Solve the following equations for x is between 0 and 360 degrees, and there was the 4 sets of equations that I wanted you to solve. Getting more and more difficult the later on we go, but this is the kind of skill and the level we have to be at in order to solve these equations at a higher level. Right, let's have a look at these. So first one, 3 sine x plus 1 equals 2. Now we could treat this like a simple equation. Now if you had an equation that said 3x plus 1 equals 2, you'd rearrange it and get x equal to 1/3. You'd look to get it in that case. It's the same style with this. You want to get it in this sort of case. The only issue is instead of x, it'll be sine x or cos x or tan x. But then we just solve it by doing inverse trig functions. So for this one, I'd rearrange it and start by getting it to sine x equals 1/3. Now from that, I can figure out what my solutions are going to be. Now remember, for trig functions, we have to refer to our cast diagram, because there's going to be more solutions between 0 and 360 degrees than just a single one because of the way the graphs work. Now it's 0 and 360 degrees, and this is a positive answer. So we know our solutions are going to lie in the A and the S parts of the diagram. So we know when we take sine minus 1, we'll get a solution in here, and then we can use that solution to find the solution in there. So we know to get x, it's sine minus 1 of 1/3. Plug that into your calculator. What you get when you use sine minus 1 of 1/3 is 19.471, and then it continues on. Then to get that second solution, so the solution that's in the S part, we do 180, take that away. So it's 180 subtract 19.471, and then the rest of the number there. Once we've done that, we can actually then round it. Ones like this, if it doesn't tell you, round to 1 decimal place, maybe 2 depending on the numbers. So in this case, what I'm going to do is I'm going to make it 19.5 degrees, and 180, take away that, 160.5 degrees. So there's my two solutions then for 3 sine x plus 1 equals 2. Next example was 2 tan x minus 3 equals 0. Same style as the last one. All these trig equations, we always want to get it into that form. Same as it would be for a normal equation. The only difference is we've got a trig part to it. So rearranging this, what I could end up getting is tan x equals 3 over 2. So tan x is 1.5. Now remember, sine and cos we can never have bigger than 1 here because of the height of the curve, but tan we can because it shoots off to infinity in the positive and negative y direction at points. So what we can do in order to get this, again, is we want to take x equals tan minus 1. Now it's a positive one, so it's going to be tan minus 1 of 3 over 2, but we need to determine where our solutions are going to be. So again, jump in with the cast diagram. It's positive, so it's going to be in the A and it's going to be in the T. You can find the solution here and then use it to get the solution there. So doing tan minus 1 of 1.5, that ends up giving me 56.3099, and then a spiel of stuff going on. And then to get the one in here, I do 180 plus that solution. So 180 plus 56.3099 and the rest of the number there. Doing that and rounding, and in this case I'll go to 1 decimal place again, get 56.3 degrees, and 180 plus that gives me 236.3 degrees. So there you go, there's my two solutions like that. Ones like this are fairly straightforward to solve. Just think of them in terms of a normal algebraic equation we're working through and solving. This one here, sine 2x minus 1 equals 0, has a slight edge to it that we need to make sure we take into account, and that's this. It's 2x. But this can be dealt with in a fairly straightforward manner. We've got our limit already of 0 less than or equal to x less than 360. If we get something like this where there's a coefficient in front of the x, take this and change it to be in terms of that. So I've got for x, what I want is for 2x. So in this case, 0 is less than or equal to 2x, which is less than double this, so 720. So what I would do is I'm going to scale the function up, find all my solutions in here, and then scale them back down when I've calculated them to get them back into the correct period that I want. So solve this to start with, and I get sine 2x equals a sixth. Again, refer to the cast diagram. Sine and it's positive, so it's going to be in the a and the s. Again, get the a, use it to solve the s. So from that, I take 2x equals sine minus 1 of a sixth. So 2x equals, well, sine minus 1 of a sixth, well, that ends up giving you is 9.594, and again, the whole spiel of stuff. Take that off of 180, so I then do 180, take away the 9.594, and I get my second solution. Now, that's me going round once, and that's 0 to 360 degrees. I want 0 to 720 though, so I have to go round a second time. So I have to go around my period a second time. So what I have to do to each of these is add on a full loop of sine, i.e. add on 360 degrees to each of these. So for the first one, I do 360 degrees plus the 9.594 in the spiel. And then for the second one, I do 360 plus this bit here. So the 180, take away the 9.594. That's how I'd get my two extra solutions for my second loop of the curve. So what I then say is fine, so 2x equals 9 well, we'll round it to one decimal place, so 9.6 degrees. 180 take away the 9.594 gives me 170.40, so that ends up giving me 170.4 degrees. And then add on 360 to both of these. So I get 369.6 degrees there. And then for my final solution, I get 530.4 degrees. So there you go, I've got my four solutions. But the only issue is, that's for 2x. And I want x, so all I have to do is half everything. So if I take those and I half them all, I get my set of answers, 4.8 degrees. Second solution goes down to 85.2 degrees. Third solution goes to 184.8 degrees. And the final solution goes down to 265.2 degrees. Each of them gets scaled back down to within my original period for the function. So between 0 and 360. So they're all now within my limits. Last one I asked you to do was 3 cos squared x equals 1. Now again, level of complexity is brought in by this part, the squared. However, it's still fairly straightforward to solve, and we still think of it in terms of a normal equation. If we had 3x squared equals 1, we divide by 3 and then take the square root. We do the exact same here. So I'd have cos squared x equals a third. I then take the square root. So I know cos x equals square root of a third. But the issue is, square root of a third squared gives me a third. But the square of negative square root of a third also gives me a third. So I've got two possible sets of solutions here. You've always got to take this into account. Always take into account the fact that when you take the square root of something, it's plus and minus. It's the positive and the negative square root could both work out to give you the answer. So what I've then got is two sets of answers. I've got cos x equals square root of a third, and I've got cos x equals negative square root of a third. So for the first one, for the positive one here, I know that that is going to give me an answer here and here. And for the second one, with it being negative, I know that that one is going to give me answers in this section here. So I'm going to have to work them all out, but then I can combine them all to get a set of solutions for the entire thing. So for the first one, cos x equals square root of a third. So I know then that x equals cos minus 1 of this, which then ends up giving me 54.7356 and a whole spiel of stuff. Now this is the solution here. So I know I'm going to get a solution in this case, this bit, and this bit because of this one. So I can just combine all four of them and get all four solutions. So my solution that would fall in the sine is going to be 180. Take away the 54.7356. My solution that falls in the t is going to be 180 plus the 54.7356. Now these would be the two solutions for this one. For this, I need the final solution, which is in the C section there, and that would be given by 360 minus the 54.7356. Get the solutions for those and round them to one decimal place. I'd get that x equals 54.7. Second solution here, the 180 minus it would give me 125.3. Third solution here would give me 234.7. And my final solution, 360, take it away, would give me 305.3. So solving these is fairly straightforward. Think of them in terms of normal algebra. The only extra issue is we've got a sine, a cos or a tan, and a wee bit of trig comes into play. Big deal.